Hey, it's me again. You're going to solve some more quadratic equations here, this time not by taking the square roots or by factoring, but by a new method called completing the square. So what makes an equation quadratic? So if I had something that said x squared equals, the fact that you have a squared here and an equal sign means it's a quadratic equation. Well, let's start off with an easy one. If x squared equals 25, you know that if you take the square root of both sides and the positive and negative on the other side here, you end up with the square root of x squared is x, and the square root of 25 with the positive and negative makes two solutions. Well, that's easy, and that's easy because 25 is a perfect square. Let me give you one that looks a little bit different. That's kind of the same idea. If I said x minus 2 in parentheses squared equals 25. Well, even though this is a binomial, the fact that it's squared means if I take the square root of it, I'm going to end up getting the stuff that's being squared to come out. Kind of like this. The square root of x squared is just x. So take a guess what the square root of the quantity x minus 2 squared is. Of course, you guessed it right. Maybe if you were wrong, I would tell you, but I can't hear you. The answer is just x minus 2. And then whatever you do to one side, you do to the other. And again, the positive and negative square root of 25 is just 5. So you end up with x minus 2 instead of just x. So now we isolate this. So if I add 2 to both sides, this looks kind of strange, but it's really quite simple. It's really just positive 5 plus 2 and negative 5 plus 2. And if you add 2 to positive 5, you get 7. And if you take negative 5 plus 2, you get negative 3. So again, you still get two solutions. Now again, why do these work out so easily? Well, it's because both sides of these equations, of this equation and this equation, are perfect squares. Well, what happens if neither one of these is a perfect square? Well, you have a new method called completing the square. Let me give you an example of what we did in, now actually this is 9-4 review. Let me make sure you understand that this is really 9-4. Now let's do what we did in 9-5. Well, if I gave you a trinomial that said x squared plus 12x plus 36, can you, and I'm going to leave this off for the time being, can you actually factor that? And hopefully you recognize that you can. It becomes x plus 6 times another x plus 6. 6 times 6 is 36. 6 plus 6 is 12. Equals. I'm going to leave the equals sign on the other side blank for the time being. Well, how do I rewrite that another way? And hopefully you recognize that it's x plus 6 squared, which kind of looks like this, doesn't it? Equals. Now, that is a perfect square, so I can take the square root of it and make it come out of the squared symbol here. I can take the square root of a square and it will just be plain x plus 6. So now I'm just going to make a random number here. What if I said 5, 5, and 5? Well, if I square root both sides, I'm going to be able to get rid of this squared symbol. So I'll go ahead and do that here, and I'll take the positive and negative square root there. What is the square root of x plus 6 in parentheses, the quantity being squared? Well, when you square root a square, it just comes out, x plus 6. And now on the other side, you have the positive and negative square root of 5, which can't be simplified. It's just an irrational number. The square root of 5 is what it is, the square root of 5. If you were to punch that into a calculator, it would just be some decimal that is non-terminating and non-repeating. It would just be a yucky number. Like, you know the square root of 4 is 2, and you know the square root of 9 is 3, so this has got to be somewhere between 2 and 3, 2.2 or something. But since it's not simplifiable, you just leave it. However, you still got to isolate x, and you know that you would just subtract 6 from both sides. You end up with x equals, now I'm going to go back to this one. Here, we added 2 to both sides, and we took negative and positive 5 and added 2 to it and got our two solutions. But since this is a radical, the way you write this is just what you see. You can't add a radical and a number together. One's inside a radical, one's not. So all you do is write it. It's negative 6 plus or minus the square root of 5. Now you're going, that doesn't look like an actual number, but it is. If I was to punch in the square root of 5 into a calculator, like I said, it would give you a decimal. So it would be negative 6 plus that decimal and negative 6 minus that decimal. And again, if we say that's just a little bit more than 2, which it is, it'd be negative 6 plus 2, which is around negative 4, and negative 6 minus 2, which is around negative 8. Those would be the two solutions. Okay, so now, what about completing the square? What happens if, when you factor this, it doesn't become a perfect square? And that's what today's lesson's all about. So in 9-6, you're not going to have a perfect square. So let me give you an example. So if I said x squared minus 6x plus 8 equals 0. Well, let's see if we can factor that. Let's see. The factors of 8 are 4 and 2. And yeah, we can get them to add up here to negative 6, but it won't be a perfect square like this. It won't be x plus 6 and x plus 6, or x plus 4 and x plus 4, or x minus 2 and x minus... It won't be that. So we won't be able to actually solve it that way. Now, this is factorable, and we could use the zero product property, but I'm using this easy example to show you how to do this new method called completing the square. Well, there's a couple of steps. Step 1. What you're going to do is you're going to isolate the constant. And the constant is negative 8. So I want to get that by itself, so all that means is you're going to move him over. So you're going to end up with x squared minus 6x, and when I subtract 8 from both sides, I get equals negative 8. Okay. Next. Step 2. It's going to sound like a lot of random steps, but you're going to kind of have to practice it to get through the entire process. Take this number, which is the second, the coefficient of x. This is a 1, this is a negative 6. What you're going to do is, off to the side here, you're going to take negative 6, and then you're going to cut it in half. What does that give you? Negative 3. Now you're going to take that number and square it, and that gives you a number of positive 9. Let me say it again. Take the coefficient of x, the middle number here, which is negative 6. Divide it by 2, gives you an answer. Square the result, gives you another number. Now you take that number, I'm going to kind of separate this here. Take that number, which I call, this is the magic box because it gives you the magic number. This is the magic number. And you add it to both sides of your equation. You add the magic number to both sides of the equation. And here's why we did that. Now let's factor it. This is step 2, getting the magic number. Now step 3 is to factor. Well, take a look at what multiplies to positive 9 and adds up to negative 6, and I'll give you a hint. It's always going to be that number right here that you squared. This will factor to x minus 3 and x minus 3 equals, and if you just simplify that, you get a 1. Well, you're going to take a shortcut next example. Isn't x minus 3 times x minus 3 squared? It is. And now let's go back to here and here. What do you think the next step will be? It will be to take the square root of both sides. So if I square root this and do a positive minus square root that, sorry, the lights just shut off. Anyway, where was I? You take the square root of both sides. Well, x minus 3 squared will come out and just become x minus 3. And the square root of 1 is just plain old 1. Now, this is just as easy as this was. You're going to finish it off by adding 3 to both sides. Adding 3 to what? Well, you're going to take positive 3 and add 1 to it. And you're going to take positive 3 and subtract 1 from it. So my two solutions are 3 plus 1, which is 4, or 3 minus 1, which is 2. And those are the solutions to this particular problem. All right, let's do another example quickly so I can get you a third example before I run out of recording time and you fall asleep. All right, here we go. By the way, this one can't be factored. There are no factors of 9 that add up to 4. So in this case, you have no choice but to use completing the square method. So step 1, move over the constant. So you're going to get x squared plus 4x, leave a hole, equals positive 9. Step 2, do the magic number box. Off to the side here. You take the number in front of x, the coefficient of x, which is 4. You cut it in half, giving you 2. You square the result, which gives you 4. This is your magic number. What do you do with the magic number? You add it to both sides of the equation. Well, why? Well, whatever you do to one side of an equation, you do to the other. Now, this is a factorable trinomial. What multiplies to 4 and adds up to 4? I'll give you a hint. It's always that number. It's going to be x plus 2 times another x plus 2, which I can just shortcut and write squared, equals 13. Step 1, move this over, the constant by himself. Step 2, get the magic number. Step 3, factor. Step 4, take the square root of both sides. X plus 2 quantity squared in the square root symbol becomes x plus 2 equals plus or minus radical 13. Notice that this doesn't have any perfect square factors. It can't be simplified. It's just a number that's a yucky decimal. So you're almost done. This is actually easier than the last problem. When I isolate x here, I get x equals, you just write what you see. Negative 2 plus or minus the square root of 13. And again, if you were to punch this into a calculator, it'd be somewhere bigger than 3 and less than 4, 3 point something. So the answer is really just a decimal of negative 2 plus whatever the square root of 13 is, like 3.4, 3.5, 3.6, and negative 2 minus that same number. So it's an irrational number. In this case, you just leave it like that. Let me do one last example. Okay, you may want to press pause after the fact here and write down these steps, because these are all the steps you have for completing the square. So in every other example, the number in front of x squared, the coefficient of x squared, was a 1. Well, in this case, it's not a 1. So in order to actually make this method work, you have to have a 1 there. Well, how do you get something that has a 3 multiplying it and to turn into a 1? Hopefully you'd tell me, hey, I just divide it. But remember, whatever you divide in one thing, you divide everything by. So step 1, make sure it's 1x squared. And the way you do that is divide. So you end up with x squared plus 12 divided by 3 is 4x equals 24 divided by 3 is 8. Step 2. Now we're going to isolate the constant, but take a look. This one already has the constant isolated. In other words, by itself on one side of the equal sign. Next, let's do the magic number. Again, we have 4 like we did in the previous example. You're going to cut that in half, give you a 2. You're going to square that, which gives you a 4 again. This is the magic number that you add to both sides. Plus 4 and 8 plus 4. Step 4 is kind of a multi-step. You factor this, you take this plus and minus square root of both sides and solve. So when I factor this, hopefully you're getting the hang of this, it's going to be what multiplies to 4 and adds up to 4? It's always that number. Whether it's negative, you'd put a negative sign. If it's positive, you put a positive sign. Squared equals 8 plus 4 is 12. Factor, take the positive and negative square root of both sides. If I square root both sides, out comes what I want, x plus 2 equals positive and negative square root of 12.
Wake up, Earl Warren.
Yes, wake up, Earl Warren. Hang on. Sorry, interrupted again. Well, radical 12 has a perfect square factor of 4 times 3, right? So let's rewrite this. X plus 2 equals plus or minus. Now, remember from the beginning of the chapter, you take the square root of the perfect square, you put it in front of the radical, and you leave whatever's under the radical under the radical. Now this looks funky, but you're almost done. And I got 15 seconds to do it. Subtract 2 from both sides. X equals negative 2 plus or minus 2 radical 3. Yucky solution, but it is actually correct. Good luck.